I'm Richard, and this is Jesse Brunner, and we're from Almira, Washington, and we're on a multi-generational
The Brunners are
small grain
2013
wheat growing
4R
farm.
Advocate winners and
It's
guests
been in
of
the family since the
TFI
early
at this
1880s.
year's Commodity Classic in Orlando, Florida, a long way from the rolling hills of central Washington. The 4R Nutrient Stewardship Report. Information about how the right source, right rate, right time, and right place interact with issues facing everyone. We visited the Brunners as they finished planting their spring barley crop.
Soil is the most important thing that we're working with, and anything we can do to improve that soil quality is something worth doing. Unfortunately, most of that stuff takes a long time, but you're never going to get there if you never start. So part of our operation is by tilling the soil the least amount possible, we allow the natural processes that take place, to do so uninhibited. This drill is the only thing we actually put into the ground. I guess you can kind of count the coulters, but they don't really move any dirt, so I don't count them. So the whole rest of the time, this ground just sits and does its natural thing. And by doing that, you can look at our soil and see how the quality's improved. When you look at it, it kind of has that cottage cheese appearance to it, whereas people that work the tar out of their soil, it just either sets up hard as a rock or just turns to dust.
Our primary source of nitrogen is a 24% solution. It's an industrial byproduct that comes to us from California. We utilize that along with 20% aqueous ammonia. It's stored both here in this tank on our air cart and also in saddle tanks on the front of our tractor. And that gives us enough of a primary source to do about 30 to 40 acres, and then we have to refill. Secondary, our starter fertilizer, is the dry material in the front box on this air cart. And we're using a manufactured product for starter. It's called MESZ. We like it because it allows us to use a lower rate and ensure that every prill, since it's a manufactured product, is identical. And we've had very, very good success with it. The primary source of the aqueous ammonia, or 24% that we're using, is transported by a pump tubing back to our drill. This knife here opens the ground. This is what we use to place our primary nitrogen source. This is placed approximately 2 inches underneath the seed. Because we're using a liquid fertilizer product, it comes in through these tubes down into this stainless, and it's deposited right at the bottom of this knife. Our starter fertilizer and seed goes down into this seed tube, and this is a paired road setup. So that means that there's 2 rows of seed, and the seed is placed at a level that's above our nitrogen and off to either side. Then we have a V-packer here, a rubber packer that goes into the slot that's opened by our fertilizer knife and then packs the seed. This drill has the capability of adjusting the pressure on both the fertilizer knife opener and also the packing pressure on the seed opener, and that's done by using the tractor hydraulics to set the pressure, and then once you set it at a level that you want it to be at, you lock the valves, and then it stays at that pressure throughout the process. When we initially started direct seeding, we ran higher pressures because our ground was a lot firmer and just required more pressure on the openers to keep them in the ground. But as we've gone on in our direct seeding process, our ground is becoming more mellower, and we've been able to cut the pressure back. Originally, we were running about 500 pounds of opening pressure on the knives, and now we're down to about 230.
Now we have Precision Ag. What we can do is we can vary the rate of fertilizer applied based on how productive or not productive each area of the field is. So I have a map here that I created using the yield monitor in our combine, which I then took and did some statistical analysis against to break our field into 3 different zones: an average zone, an above average zone, and a below average zone. I chose 3 zones. I could do as many or as few as I like. 3 seems to work for us. And then based on our position in the field, the monitor varies the rate of fertilizer that we put down. In our above average areas, I put 20% more. In our below average areas, we put 20% less. Our GPS system, which is accurate down to about an inch, lets the computer know exactly where in the field we're at. And then based on how I have my map set up, it knows whether to apply one rate or a higher rate or a lower rate based on our location. I'm not putting any more or less on this field that I would have before Precision Ag, but I'm putting it in different spots so I get more benefit from the higher yielding areas, and then I don't burn the lower yielding areas with too much fertilizer. So, there's a big increase in efficiency there, which does come out in our yields. The other big difference is we've gone from, a 15% overage before we had Precision Ag down to a less than 1% overage. And that's a huge cost saving since we only basically drag one piece of equipment through the field. We're putting a lot of product into the ground. It's an expensive operation. So reducing our overage by, 12% is huge for us.
For more information about 4R advocates and the 4Rs, visit nutrientstewardship.com.